Before we start off, let's go through the basic anatomy of a standard raised panel door. You've got the horizontal members, which are called rails, the vertical members, which are called stiles. They work together to form the frame, and then you've got a raised panel that is seated inside the frame. The frame itself is held together by stub tenons, and then the panel is trapped in a groove that runs along the perimeter on the inside of the frame. I've put this sketch together to help me calculate the length of my stiles and rails. I'll be creating a door which is 14 inches wide by 16 inches high, and will feature rails and stiles that have a width of 2.5 inches. Now the length of my stiles will be equivalent to the height of my door, which is 16 inches, and the rail length will be equivalent to the width of the door minus the stile width times 2 plus the stub tenon length times 2. This works out to be 9 13/16 inches. Now we're ready to select and cut the stock for our rail and stile parts. I've cut my rails and stiles to size. For smooth rips, I like to use Freud's glue line rip blade, and for accurate crosscuts, I choose Freud's ultimate cutoff. However, if you're somebody who likes to use one blade for both ripping and cross-cutting, Freud's Premier Fusion is an awesome choice. Now we're ready to get routing the component parts of our door. The first thing that we'll want to do is route the stub tenons on the end of our rails. But before we set up the bit, we'll want to make sure that the router is unplugged for safety concerns. Next, we'll want to take the bit and insert at least 80% of the shank in the collet before we lock it down. We're working with 3/4 inch stock, so we'll want to lower our rail bit so that we produce an 1/8 inch shoulder. Remember, the outside face of the rail is always going to be face down on the router table. Now I'm going to lock down the height of the router bit. I'll also need to make a few adjustments with my fence. I'll use a straight edge to align the bearing on the router bit with the fence. I'll also need to pull the wings in closer to the bit, but not so close that the cutters end up hitting the wings. To cut the stub tenon, I'm going to use this plywood backer block to keep the material stable and square to the fence as I make the cut. Now, for best results, make a test cut in a scrap piece of stock to ensure that you have the profile, stub tenon, and back shoulder aligned in the material thickness. Once you're happy with the bit setup, cut all of the stub tenons on the end of your rails. Also, make sure to use hearing protection, ANSI rated safety glasses, as well as the safety guard on your router table. I've finished routing the ends of all my rails to produce the stub tenon. With this done, I've unplugged the router, replaced the rail bit with the stile bit, and now it's time for me to adjust the height of the stile bit. I'll do this by aligning the slot cutting portion of the stile bit with the stub tenon. When I've arrived at a height that I feel comfortable with, I'll lock the bit in place, reset the alignment of the fence, and I'll make my sample cuts. Now I'm going to check my stile cut with my stub tenon, and I can see that I've got a perfect flush finish, and I'm ready to route the rest of my edges. I've assembled my door frame and everything fits together perfectly. At this point, I need to find the dimension for my raised panel. I'll do this by measuring the visual opening. It's 9 inches across and 11 inches from top to bottom. To these numbers, I'll add 13/16, which represents the depths of these grooves. For the width of the panel, I'll also need to subtract an additional 1/8 of an inch to allow for wood expansion across the grain. For the height of the door, I'll need to subtract a 1/16 of an inch, which will help to keep the panel from binding. The finished size of my raised panel will be 9 11/16 by 11 3/4. With these numbers, I'm ready to size the stock for my panel. I've sized my stock and now I'm ready to route the profiles to create my raised panel door. I've unplugged my router and I've inserted a raised panel bit with a back cutter. I've put at least 80% of the shank in the collet and I've locked down on the collet nut. Now to produce a raised panel that will be flush with my door frame, I'll align the stub tenon of one of my rails with the space between the raised panel cutter and the back cutter. For safety purposes, it's important to adjust the router to the correct speed for the router bit. For this large diameter raised panel bit, we've reduced the speed to 12,000 RPMs. We also recommend that you route your raised panels in 3 passes. With this in mind, I've adjusted the fence so that only 1/3 of the cutter depth is exposed. I've also adjusted the wings so that they're close to the cutters for maximum support. Here's a tip. Always make the first cuts across the grain of the wood, then follow with the side grain. This reduces the chance of tear out. I've got my safety glasses on and my hearing protection, and now I'm ready to route my raised panel. I've made the first 2 passes on my raised panel, and now I'm ready to make the finished cut. I've turned the router off and I've unplugged it, and with a straight edge, I've aligned the pilot of the raised panel bit with the fence. I've finished routing the raised panel, and now it's time for me to assemble my raised panel door. Now for the final assembly, I'll just glue the corner joints and I'll let the raised panel float. And that's how simple it is to build a raised panel cabinet door.